Hey guys, it's 2 in the morning and I'm feeling awful, so I'm going to make you a video so that I can call a sub and not have to try to teach this way in person. So if you take a look at this top example right here, I've given you a first term and I've given you a ratio, and I'm asking you to find the sum of the first 100, 200, and 300 terms. Now, just as a reminder, the formula that you have for geometric series looks like this. It's the first term times 1 minus r raised to the n all over 1 minus r. So each of these three calculations that I'm asking you to do are going to be similar, okay? And they're going to look like this. And if you put each of those into your calculator, you will amazingly find that they all have the exact same answer. They all have the answer of 2. Okay, so it doesn't matter whether you're adding up 100 numbers, 200 numbers, or 300 numbers. In this particular case, they're going to add up to be 2. And the reason is because this ratio is a fraction that is less than 1. So the numbers are getting smaller and smaller and smaller. The first number is a 1, and then the next number is 1/2. And then the next number is 1/4, and then it's 1/8, and then it's 1/16, and then it's 1/32, and they're getting so unbelievably tiny and microscopic that they end up not affecting the sum. So when that happens, it's called an infinite geometric series, and there's a formula specifically for this. It's your fifth and final formula, and actually it's the easiest one. Okay, so you can see it right here. All you need is the first term and the ratio, right? And this formula only works if the absolute value of your ratio is less than 1. Okay, so it has to be a fraction or a decimal that's less than 1. And notice that there isn't any subscript on this S, meaning we're not finding the sum of the first 100 or 200 or 800. We're finding the sum of all of them. Even though they never end, you're finding the sum of all of them. Okay, so I have 3 examples here. We're going to try and get through them. Hopefully my voice will hold out. Okay, so if I started to, actually, before I even start this example, notice that it's asking me to expand this forever, right? That's what that infinity means. That you're going to plug in 0, then you're going to plug in 1, then you're going to plug in 2, and you're going to plug in 3, and you're going to just keep going forever. So if I plug in 0 in for n, I get 6. And if I plug in 1, I get 4. Right? And you can keep going with that. You can fill in as many as you want. But more than anything, I want you to see that a sub 1 is 6 and that the ratio is 2/3. And because this ratio, the absolute value of it, is less than 1, I get to use this brand new formula. So I'm going to write the brand new formula, and I'm going to plug in my numbers that I know. So a sub 1 is 6, and the ratio is 2/3. So 1 minus 2/3 is 1/3, and 6 divided by 1/3 is 18. So the sum of all those numbers is 18. Okay, I'm going to move this up a little, and then we're going to try this next one. All right, so again, if I expanded this out, it's saying to keep expanding forever. But if I plug in 0 as my first term, not as my first term, but to get my first term, I get 9. When I plug in 1, I get my second term as, what is that, -6. And again, you can keep going. You can fill in as many as you want. But all I did this for is to figure out that my first term is 9 and that my ratio is -2/3. So when I go to use this formula, where all I need is the first term and the ratio, first term is 9. 1 minus this ratio of -2/3 gives me 9 over 5/3. 9 divided by 5/3 is the same as 9 times 3/5, which equals 27/5. All right, And then my last example here, you won't always see them in summation notation, right? You can see them just as regular old problems. Notice here that this ... means that this goes on forever. It is implying that's an infinite geometric series. So I can see that my first term is 9. I can figure out that my ratio is 2/3. And I can then apply this formula. So here we go. First term is 9. The ratio is 2/3. So now I have 9 over 1/3. And 9 divided by 1/3 is 27. All right, I hope that helps, and I hope that I feel better and am at school tomorrow. Feel free to shoot me an email if you have questions. I'll do my best to answer. And I hope to see you soon.